Okay, hello friends, I think we're live, and in this live stream I would like to address my recent channel name change, because if you noticed, I changed my channel name from Physics, Math and Me to Spin. So as you can see, I now have a new channel name, and this will reflect much better what the channel is going to be about, and in a minute I'm going to explain why I chose this particular name. Okay, so when I started my undergrad physics degree, I quite frankly didn't know where this will take me. I was confused about what I'm going to be doing in the future, and I wasn't sure where I will end up career-wise. And now that I'm in my last year of the physics undergrad, this year will be the final year, and I have much clearer understanding of where this path is going to take me. And I think this is going to be another exciting couple of years. Very much physics related, but also incorporating some new advancements in the computation technology and in artificial intelligence research and things like that. So let me start with the following. As you know, last summer, well, this summer, I did a research project on the artificial spin ice, which was mainly programming. So all I did was doing some programming for another graduate student who is working currently on the artificial spin ice system. And I was helping with the simulation of the data, or better to say, with the visual aspect. So creating visualizations to better understand how the system behaves. And as a result, I've learned a decent amount of Julia programming language and how to use it more or less properly, even though there's still a lot to learn. But now it's time for myself to learn more physics of that process, because I am continuing with the honors physics degree. So part of my this year's studies will be a research project, a physics research project that will involve working on the artificial spin ice system that's different from what the student I'm working with right now is doing. And yeah, so this is what I will be doing most of the time from now on, and well, besides the classes that I will be taking as well. And the whole idea of that research is actually, well, the purpose, what we're trying to do is to try and develop new mediums for computations, to try and develop new materials that will be helpful in creating new generation of computer chips that will be more human-like, if you wish, well, basically mimic the brain workings. And to make it clear, let me show you something. So I will be working on something that called reservoir computing, or not directly on that, but we will try to work to develop a system that will allow computers or allow this magnetic material to work as a reservoir for so-called reservoir computing. This is not a new concept in general, but it's a concept that has kind of seen new life, right? Like new, fresh start in the recent years, people starting to look back at it and incorporate the ideas in recent researches. So this is a little extract from the newsletter I'm writing for my blog, and I'm almost ready with this. So this is a sort of the idea behind it. That's a kind of neural network. The difference here is that what will serve as this reservoir here, what will be the computational medium. So there are several types of those reservoirs being studied right now. Some of them are of the quantum nature, some of them optical, and some of them are artificial spin ices. And this is what we are studying. And so there are many possibilities of what you can consider a reservoir. So we happen to work on the artificial spin ice systems. And that reservoir, the system itself, will have to be very similar, or ideally it will have to very similar working properties to our brain. Because our brains are processing information very fast, very energy efficient, and they're highly nonlinear. They can work like our brain works in massively parallel ways. And this is what is so exciting in this research, because it should be possible to create materials that will serve similar purpose or will work similarly. We're just trying to find a proper medium that will be working in a similar fashion, pretty much. So I will post more on that later in future videos, and to explain more in detail what we're trying to do. I won't go too much into detail into my own research project, probably because for the obvious reasons for, it's not published work yet. Yeah, but this is kind of the direction. And I like the idea so much that I don't know, I probably have never been so passionate about the project as I am right now. And oh wait, I probably didn't share my screen. I think I just switched sharing. Wait a second. Okay, yeah. Okay, anyway, I probably should start over. Okay, so that's the picture I was talking about, the reservoir computing and the reservoirs that are possible. Well, quantum, optical, or artificial spin ices, and there are a few others. And yeah, so this is the blog post, not the blog post, actually blog newsletter kind of part of it. To kind of visualize the idea of the neuromorphic computing. So that's some papers I found quickly to illustrate what I mean. Yeah, so basically this is how the human brain processes information, and this is what we're trying to mimic, to create a system that will be working in highly non-parallel, non-linear ways, similar to the brain, and make the computation much faster, much more energy efficient. And yeah, so this can open many new horizons. Okay, so now that we covered this, I also would like to address some other content on the channel. I think there will be a few programming videos coming on the Julia language, because through the research project I was doing, and since this will be my main tool for working on my own research project, I will be covering Julia language in some future videos as well. I'm doing it already on my blog. You can find the link to my blog on my channel, and also in the description there are links if you like. And what was I gonna say? Yeah, so I could quickly show you something. Okay, so here's the link to the blog, and this is how it looks like for now. It's not perfect yet. There is still a lot of things to do in terms of content and layout and things like that, but it is quite nice, and I'm glad that people read it. Actually, this is my first exciting and successful project when it comes to content creation on the web. And yeah, so that's a fun project to work on, even though it's quite time consuming, but I do like that stuff. And as a fun fact, I made my first dollar with that blog already, and like in the month and a half or 2 months that I'm working on that. Well, $1 is funny. It's not very big money, of course, but it's a good start, and it's my first dollar earned on the web. And to make it clear, I'm not after big money or anything, but I clearly do want to make some income from it because I'm spending quite a bit of hours working on that, and hopefully it's helpful for people, and it also helps me to well, pay the bills and study physics, continue with my research, because doing research, especially as a student, even graduate student, does not really pay much, but that's kind of my goal, to help build up that income a little bit to make it a decent contribution to our family budget. But anyways, this is off topic, and if you're interested about anything on how to set up a science related blog, or how I run it, what I do for all kinds of things, including monetization, I will be more than happy to help, or maybe create future videos, who knows. Yeah, so that's my 5 cents to that. And I think that's it. I think that's all I wanted to say, and it's been a while. I meant to keep it short. So I think I am going to stop here. It's quite late, and I'll see you soon, guys. I see you probably next week. I'm aiming to post 1 video per week now. And yeah, I wish you a good day or good night wherever you are. And see you later. Bye.